Welcome to Brain Vision.
So welcome to this question here, and we have interesting question here. We have this, there are two objects here, and we have object of mass 1, and then we'll have another object of mass 2 there, and we have a string that connects them. Okay, so we expect movement to be that and that, so which means we expect object 2 to be there at some point and object 1 will be there at some point. Okay, and this would be the height, the displacement here we expect. All right, so therefore the same height should be there if we expect it to fall. So therefore, because mass 1 is given as 3 kilograms, 3.0 kilograms, mass 2 is given as 5 kilograms, and the height there is 1.5 meters. So therefore the coefficient of friction is 0.4. So if we apply the principles of conservation of mechanical energy, therefore change in K plus change in U plus W external should give you 0 basically. So in other words, you're trying to say like F final and K initial, okay, plus U final minus U initial, right, plus F for that is the force, multiplied by S should give you 0. Now remember that UF minus UI is expression for minus M2GH that we expect there. Okay, because the system starts from from rest, so therefore Ki is 0. And frictional force, I'm gonna call that F is perhaps the constant, multiply that by mass 1, multiply the gravity, force of gravity, because S is h, which is basically this distance displaced or traveled by the system. So therefore we are trying to say that half of m1 and m2 multiply that by v squared minus m2gh plus the constant multiplied by the m1 mg should give you 0. So therefore V for the system will be equal to 2 multiplied by m2gh minus the constant and m1g divided by m1 plus m2 okay, and then we put all these up to power half. So in other words, we're trying to look at 2 multiply by 5 multiply by 9.8 multiply that by 1.5 minus 0.4 multiply that by 3 multiply that by 9.8. You divide all that by 8. Okay, you know, I've just added to the two weights, raised to power half. So eventually expect approximately 8.74 meters per second, and that is your final velocity.